Hello, this is part three of derivatives tests. Continuing on derivatives test. So let's start with 23. So 23 says f of x is a differentiable function for all x, and g of x equals 3x squared minus 1. And they give us a table. Yeah, they give us this table, and we got to find h prime of 1. So how do we find h prime of 1 when they give us a table and they give us g of x? Yeah, how do we do this? Let's see. So find h prime of 1. What do we know? We know that h of x is g of x over f of x. Uh, yeah, that should be given. I didn't write that down. So this is also part of the equation problem. H of x equals g of x over f of x. That this should be given. I didn't write that down. So they want h prime of 1. So let's take h prime of x. So how do we take h prime of x? It is a fraction. We must use the quotient rule, right? So quotient rule is f of x times g prime of x minus g of x times f prime of x all over f of x squared. Okay, so now this is where we're going to need the table. Maybe we should plug in 1. I think that would be helpful. So let's plug h prime of 1. So it's going to be f of 1 times g prime of 1 minus, and I'll put a little bracket so I don't, yeah, g of 1 times f prime of 1 all over f of 1 square. So this is where we're going to need the table. F of 1, where's f of 1? So here's f of x. If I plug in my x value 1, it spits out a y value of 3. So that's going to be 3. Now let's find g prime of 1. So the good news, they give us this, g of x equals 3x squared. So g prime, let me write that out. This we don't look at the table, we just use our calculus skills. So g of x equals 3x squared minus 1. G prime is going to be 6x, and then derivative of negative 1 is 0. So g prime of 1 is going to be 6 times, and then replace x with 1, so that is 6. Minus, bracket, and then g of 1. That's easy. We just look at the g of x function and then just plug in 1 into the function. That's 3 times 1 squared minus 1, so that's 3 minus 1, which is 2. G of 1 is 2. And then f prime of 1 is, we look at the table, here's the f prime. If we if we plug in 1 into f prime, it spits out 2. All over f1 squared. So f1 squared, that would be 9, right? Or it would be 3 and then square that. Okay, now we just do some algebra. 6 times 3 is 18, minus 2 times 2 is 4, over 3 squared is 9. That would be 14 over 9. Can it be reduced? No. So that is my final answer, 14 over 9. There is a part B. Part B says, write this down. The part B says find if h of x equals f of g of x, right? So if h of x equals f of g of x, it's the same thing as fog, right? This is the same thing as fog. They want you to find h prime of x. So this is basically a chain rule. And then they want you to find h prime of 1. So let's find f h prime of x. So how do you take the derivative of a chain rule? It's just f prime of g times g prime. And then h, they want you to find h prime of 1. It's pretty simple. It's just f prime of g of 1 times g prime of 1. So what is g1? You look, g of 1 is, you don't look at the table that was given. G of, wait, let me write, g of x was given. I can write it down here. So yeah, g of 1 would be, okay, this is easy. 1 squared is 1 times by 3. That's 3 minus 1, just 2. And then, so it's going to be f prime, and then we replace g of 1 with 2 times g prime of 1. So let's find g prime. This would be 6x, and then g prime of 1 is 6 times 1, which is 6. Okay. So how do you find f prime? F prime 2. So we look at the table. Okay, so here's f prime. If you spit out, if you plug in 2, it spits out 5. So f prime of 2 is 5. Okay, so f prime of 2 is 5, and then times that by 6, it gives you 30. Okay, so that is the answer for part B. Let's move on to 24. 24, y equals sin square of 5x, find y double prime. So how can sine square of 5x, did you know you can rewrite that as y equals sin of 5x to the second power? Yes, you can. You can rewrite this as this. Now let's find y prime. How would I find y prime? What do I have to use? You need to use the power rule and chain rule. So start with power rule. So this has a coefficient of 1, so 1 times 2 is 2. Leave the inner parentheses alone. And then old power minus 1, so 2 minus 1 is 1. Then you apply the chain rule. So you take the derivative of the inner parentheses. So it's like, how do you take the derivative of sine of 5x? Yes, you got to take the chain rule again. So it's like taking the chain rule twice. So start with sin. What's the derivative of sin? That's one way you could do it. Yeah, so so the derivative of sin is cosine, leave 5x alone, and then you take the derivative of 5x, which is 5. Or the other way you could do is right, no, we're actually that's right. So yes, we were my mistake. We were doing it correct. So let me recap what I did. I took the power rule, 2 times 1 is 2, leave the inner parenthesis alone, then take the derivative of the parentheses. So what's the derivative of sine 5x? It is cosine of 5x times the derivative of 5x, which is 5. So y prime is going to be, you can clean this up a bit. You can multiply 5 and 2, which is 10. Or no, you could put the 5 in front. No, no, no. This is okay. What you could do is this is y prime. You can rewrite this as sin of 10x times it by 5. Because all I did was I multiplied this 2 by 5, which is 10, and I have this 5. I'm sorry, my mistake. I'm so lost. I'm like, what you could do is use your identity. We know that 2 sine of x times cosine of x is equal to sin of 2 of x, right? And we also know that, and another example is if you have 2 sine of x times cosine of sine of x is the same thing as sine of 14x. So use these properties to simplify it. See how they have a sine of 5x, sine of 5x. So what you would do is multiply, that's going to be, you have a sine and a cosine. So now that's going to be sine. So that's going to be, so y prime is going to be sine. And then you're going to multiply, since these are the same, you're going to multiply 2 by 5, which is 10x. And then you have this extra 5. So you put that in front. Okay. So I had to use this identity to simplify it. I know that sine of the same number times cosine of the same number is just going to be 7, whatever that number is, times it by this number. And you're just going to put a sin in front. And then I had this extra 5, so that is going to be 5 sine of 10x. Okay, so that is my y prime. That was a tricky one. Now let's find y double prime. So how can I find y double prime? Not too bad, right? What I could do is rewrite this. What can I do? I could factor out the 5 and just take the derivative sin of 10x. If you want, you could put a parentheses here. So how do we take the so remember if 5 is a constant, so you could just ignore it. All you got to do is take the derivative of sine of 10 of x. So I know you got to use the chain rule. So the derivative of sine is cosine. Leave 10x alone times the derivative of 10x, which is 10. Okay, and then you still have this extra 5. So y double prime is going to be uh, you multiply the 5 and the 10, which is 50. and then you have cosine of 10x. Okay, so that is number 24. Okay, let's move on to 25. So 25, we have y equals 1 over x plus cotan of x, and we got to find y double prime. So I'm going to have to first find y prime, but before I do find y prime, I don't like this fraction, 1 over x, right? I just don't like it. I'm going to rewrite it as a negative power. So 1 over x could be expressed as x to the negative 1 plus cotan of x. That's much better. Now I may take the first derivative, much easier. So what's the derivative of x to the negative 1? Use power rule, right? So negative 1 times this coefficient is negative 1 x, and then all power minus 1. So negative 1 minus 1 is negative 2. And then the derivative of cotan x is negative cosecant. Negative cosecant squared of x. Okay, so this is y prime. Now let's find y double prime. So over here, negative 2 times negative 1 is positive 2 x, and then old power minus 1, so negative 2 minus 1 is negative 3. Now, how do I take the derivative of negative cosecant square? Let's see, negative cosecant square is the same thing as negative cosecant squared x to the power 2, right? That is the same thing. So you're going to have to use power rule and chain rule. So let's start with the power rule. So 2 times negative 1 is negative 2. Leave this alone for right now. And then old power minus 1, so 2 minus 1 is 1. Then you take the derivative of cosecant, because that's part of the chain rule. So what's the derivative of cosecant? It is negative cosecant of x times cotan of x, right? And yeah, okay, then go ahead and clean it up a bit. You have y double prime equals 2x to the negative 3 is the same thing as 2 over x cubed. Over here, a negative and a negative is a positive, so that's positive 2 cosecant square of x times cotan x. Okay, so that's your final answer. Okay, let's move on to 26. 26, we have a fraction, f of x equals x over x minus 1, and we got to find f double prime. Yeah, I guess you could just use the quotient rule to find f prime. There's nothing else I could do more. So if you recall, quotient rule is f prime of g minus g prime of f all over g squared. So your f is the numerator, so your f is x, and your g is the denominator, which is x minus 1. F prime is 1. G prime is the derivative of x minus 1 is 1. So f prime of x is going to be f prime is 1. G is x minus 1 minus bracket g prime is 1 times f, which is x, all over g squared. Okay, now if you want to clean this up, 1 times x minus 1 is x minus 1. 1 times x is x, and then you subtract it, so that's negative x over x minus 1 squared. You clean that up a bit, the x and the negative x cancel, so you're left with negative 1 over x minus 1 squared. Okay, so here's your f prime of x. Now we got to take f double prime. And I don't want to use the quotient rule. I could technically do the quotient rule, but I could actually use power rule and chain rule. How could I do that? Well, I could rewrite this negative 1 over x plus x minus 1 squared. I could write that as a negative power. So it would be negative 1 parentheses x minus 1. And then instead of positive 2, I will use negative 2, right? So do you agree that this right here, negative 1 parentheses x minus 1 to the negative 2, is the same thing as this? Good. Now I can find f double prime by using power rule and chain rule. So start with power rule. Negative 1 times negative 1 is positive 2. Leave the inner parentheses alone. And then old power minus 1. So your old power is negative 2 minus 1, which is negative 3, times the derivative. Now you apply the chain rule. So the derivative of x minus 1 is 1. Clean this up. 1 times 2 is 2. X minus 1 to the negative 3. And then if you really want, you can rewrite this as a positive power, unless your teacher says so. If not, you can just leave it as this. So you can rewrite this as 2 times 1 over x minus 1 to the third. So f double prime is 2 over x minus 1 to the third. Okay, so that's your final answer. Okay, let's start. Now let's move on to 27. We got to find, so we're given f of x equals tan of x, and we got to find f triple prime. So the third derivative. Let's start with f prime of x then. So what's the derivative of tan of x? It's something you should know. It's secant square of x. Now, if you want to rewrite secant square of x as secant of x raised to the second power, just to make it easier to find the second derivative, that's fine. So that I'm going to do that. So f double prime, how do I take the derivative of this thing? Yes, you're right. We must use the power rule and the chain rule. So start with the power rule. So 2 times 1 is 2. And then it's going to be secant of x. And then old power minus 1. So 2 minus 1 is 1. And then you apply the chain rule. What's the derivative of secant of x? It is secant of x tan of x. Okay. What can we do here? So I guess you can rewrite this as, you can clean this up a bit. Secant of x times secant of x is secant square of x. And then you have this tan of x. Now, what else could I do? This is not my answer. I want f triple prime. So exactly what, in order to find f triple prime, you must use the product rule. Well, since 2 is a constant, you could just take that out, factor it out, and then distribute that 2 at the very end. And how would I apply the product rule? So product rule is f prime of g plus g prime of f. And f is secant square of x. F prime is What is the derivative of secant square of x? It is 2 secant square of x. Wait, no, that's wrong. Actually, you know what? I'm gonna rewrite this as I'm gonna put the tan x first. I think that'll be easier. So I'm gonna write 2 tan of x times secant square of x. That's much easier. You could factor out the 2 or now, or you can just say f is your 2 tan of x. I think that'll be easier. So my f is 2 tan of x. What's the derivative of 2 tan of x? It is 2 secant square of x. Correct? And then my g is secant square of x. My g prime is what is the derivative of secant square of x? Is going to be use the power rule and the chain rule, and when you put it all together, you should get 2 secant of x times secant of x times tan of x. Ah, yeah, that was going to happen. Okay, right here. So if g is secant square of x, g prime, let me write it here, is 2 secant of x times secant of x times tan of x. Right? So we have everything we need. So just apply the product rule. So that is going to be uh, it's going to be f prime, which is so when you put it all together, let me just save you the algebra. When you apply the product rule, it's going to be 4 tan of x times secant of x times secant of x times tan of x plus 2 secant square of x times secant square of x. And when you clean this up, you're going to get 4 tan square of x secant square of x plus 2 secant square of x. Okay, so that is 27. Okay, let's move on to 28. So we have in 28, we have x squared plus y squared equals 4, and we got to find the second derivative implicitly. So what I would do first is, yeah, this is implicit differentiation, and we got to take it the derivative in respect to x twice. The first I would have to do is find dy dx, right? dy dx means taking the derivative of each term in respect to x. So let's do that. So start with x. The first term is x squared. What's the derivative of that in respect to x? It is 2x, and then you have the option putting in respect to x. You do have the option putting dx over dx. Why dx over dx? Because we're taking it in respect to x, so that's what I put in the bottom. And then on the top, it's whatever your letter is. We have it in x, so dx. But what do you notice? The dx cancels. So you don't really need to do that. Plus, what is the root of y squared in respect to x? So take the root of y squared in general. So it would be 2y. And then you will have to add the dy dx. Why do we have to add the dy dx? Well, the dx is because we're taking it in respect to x. The dy on the top is because we have the letter y. That's how I remember it. And then the derivative for constant is 0. So you have 2x plus 2y dy dx. So 0, and then go ahead and solve for dy dx. So I'm going to subtract 2x. This cancels. You're left with 2y dy dx equals negative 2x. And then last step, solving for dy dx, get rid of this 2y. So you're going to divide both sides by 2y. So you get dy over dx equals, and then as you can see, the 2 and the negative do cancel, so you're just left with negative x over y. Now, is this our answer? No. We got to find the second derivative in respect to x, so you got to use what's called the quotient rule. So yeah, just use the quotient rule. If you recall, the quotient rule is this: f prime of g minus g prime of f all over g squared. Okay. So figure out your f and g. Your f is the numerator, which is negative x. Your g is y, the denominator. And we're taking it the derivative in each term in respect to x. So f prime, the derivative of negative x is negative 1, and then you don't have to put the dx over dx because that cancels. And then g prime is the derivative of y is 1, and then you must add the dy dx. Okay. Okay, so go ahead and apply the chain rule. I mean, not chain rule, quotient rule. Okay. So it's going to be negative. Okay, so it's f prime of g minus g prime of f all over g squared. So what are we going to do? So f prime is negative 1. G is y minus g prime, which is, let me put a bracket. G prime is 1 dy dx. And then f is negative x all over g squared. So g is y, and then I'm going to square that. This should be 2 because we're taking it twice. So if you clean this up, negative 1 times y is negative y minus bracket. Over here we have 1 times dy dx. We know from the previous answer dy dx is negative x over y. Times it by negative x all over y squared. Okay, so this is going to be negative y minus bracket. 1 times negative x is negative xy. Times it by negative x. over y squared. Uh, you have a complex fraction over here, negative times a negative, so that's going to be negative y minus negative times a negative is positive x squared over y. All over y squared. So yeah, we have a complex fraction. Let's simplify the numerator. This has a denominator 1, so multiply this. This has 1, so your LCD is y, so multiply this top and bottom by y. So that's going to be negative y squared minus x squared over y. I mean, all over y, right? And then all over y squared. So when you clean that up, yeah, when you clean this up, you should get, when you clean this up, you should get negative y squared minus x squared all over y cubed. Then what you could do is you could factor out this minus on the top. So it's going to be negative parentheses uh, y squared plus x squared over y cubed. And there's one thing we know from if you go back to our previous problem, we know that x squared plus y squared. So if you go all the way to the top of your previous problem, x squared plus y squared equals to 4, right? So you're going to replace this with 4. So it's going to be negative negative. So I'm replacing y squared plus x squared with 4 because that was given. So it's negative 4 over y cubed. And so this is your final answer. This is the second derivative in respect to x. Okay, so that was a kind of like a longer one. Let's move on to 29. Twenty-nine says we have f of x equals cosine of 2x. We must find f prime of x. So this one's not too bad. How would we find this? It's just we take the derivative cosine. We use the chain rule, right? So what's the derivative cosine? It is negative sine, and then leave the 2x alone, right? And then what you do is take the derivative of 2x, which is 2. So f prime of x is going to be, you put the 2 in front, so this would be negative 2 sin of 2x. Okay, so that's your final answer. Okay, number 30. Number 30 says write the equation of the tangent line at pi over 2, and then it should say of the equation y equals x sin of x. Okay, so write the equation of the tangent line at the point pi over 2, comma pi over 2 at the equation y equals x sin of x. So whenever they say find the equation, you're most likely going to use point slope form. So first, what I would do is check if we actually have a point, an x and a y coordinate. Sometimes they can be tricky, but sometimes they will give you only an x coordinate, and at the very end, you don't know what your y is. So always check. So we do have an x and a y coordinates, right? We do. Your x coordinates pi over 2, your y coordinates pi over 2. Step 2 is we're going to find m. So how do you find m? So they give you y equals x sin of x. What you got to do is apply the product rule, and then you plug in your x coordinate or y coordinate or both, because remember, slope is a constant. So let's do that. So how do we take the derivative of y equals x times sine of x? We must use the product rule. Okay, so your f is x, your f prime is 1, your g is sine of x, your g prime is cosine of x. Okay, so apply the product rule. Product rule is f prime of g plus g prime of f. So let's do that. Y prime is f prime, which is 1. G is sine of x plus the g prime, which is cosine of x, times it by f, which is x. So 1 times sine of x is just sine of x, plus cosine of x times x is x cosine of x. Okay, now, because slope is a constant, we got to plug in, I think we just got to plug in our x coordinate because we don't have a y coordinate, right? So it's going to be sine, wherever you see an x, plug in pi over 2, plus x, which is pi over 2, cosine of pi over 2. So sine of pi over 2 is, you can use a calculator or you can look at your unit circle. So sine of pi over 2 is 90 degrees, right? 90 degrees is right here. It has an x coordinate of 0 and a y coordinate of 1. So the sine is the y coordinate, so that would be 1. Plus pi over 2 times cosine of pi over 2. So pi over 2 is 90 and the cosine or the x coordinate is 0. So 0 times pi over 2 plus 1 is 1. So your slope is m equals 1. Okay, now our final answer has to be in point slope form because they said find the equation. So step 3, put it in point slope form. So point slope form is y minus y1 equals to m times x minus x1. Okay, so we have everything we need. We know that our slope is 1. We know that my x1 and my y1 is given. X1 is the coordinate, which is pi over 2. Your y1 is also pi over 2. So it's going to be y minus y1, which is pi over 2, equals to m, which is 1, times x minus x1, which is pi over 2. Okay. You can leave it like this. Usually they prefer point cell form. You could do one extra step. You can try solving for y. So if you do that, 1 times x minus pi over 2 is just itself. Solve for y by adding pi over 2. You get y equals x, and then negative pi over 2 plus pi over 2 is just 0. So this is perfectly fine. This is also perfectly fine. Okay, we will stop here. We'll do another part as there's, yeah, many questions on derivatives. So I'll stop here and then I think we'll start on 31.